All right, now we're going to talk some more about pointers. So let's just review what we were talking about pointers. So we have 7 data types that we've learned so far in this class. Those data types are int, double, char, int pointer. That means that's a pointer that points to the location in memory where an integer is. A double pointer, that means that it is a data type that points to a location in memory where a double is. A character pointer, same thing, and a file pointer. So far, all of these data types are very different. They have very different rules on how you can use them, declare them, allocate them, etc. So I'm going to draw my memory map over here, and in this example we're going to do characters. So this is memory. This represents your RAM on your computer. Of course, this is a very small representation of the RAM. So I'm going to just do a little bit with characters because maybe it might become a little bit confusing when you're dealing with numbers. So this would be the beginning of your RAM, starts at location 0. Now once again, where things are located in memory depends on each execution of a program, and it will be different each time a program is executed. Now let's just say I'm in my main function here, and I declare a character, and I call that character letter, and I assign it the value A. So what this declaration right here, this is a declaration with initialization. What this does is it gives me when this statement gets executed, my operating system will find a location in memory and say, oh, look, here's a free whatever. There might be something here, and there might be something here, and there might be something here. Oh, here's a free spot in memory. So this is a location. This location might be at byte 500, let's just say, for example. So this location is at 500, meaning this is 0, this is 1, 2, 3, 4, 5, 6, 7, 8, 9, da 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 da, and this is location 500. This is a not to scale representation. This could be any location. I just picked a number just so I would have something concrete for you to understand. So this could be location 500, this could be location 100. And then this is all broken up into more pieces of memory, etc. So this is location 500. This is a free spot in memory, so then it's going to put this letter A at that location. And because we gave it a name, the name of it is let. I'm going to declare another character, char let2, and assign it the letter B. This is just demonstrating what pointers, how pointers work and what it looks like. So here, now we go through memory. Oh, here's another free location. This happens to be location 1200. Again, I just randomly picked some kind of number, and we're going to place the letter B at that location, and it's going to be called let2. I'm going to declare a double. My double is going to be called pi, and I'm going to assign it the value 3.14. My operating system is going to find a free location. Oh, it happens to find this free location down here. This happens to be location 1400. Not to scale, it doesn't matter. I'm just saying. Then it puts this value of 3.14 here, and it is called pi. The names over here, these are the variable names. That's how we reference these variables. Pi is a double, and it happens to be at this location during this execution. During another execution, it could be at a completely different location. Now, how do we access it in C? By the location. All you have to do is take that variable name and put an ampersand in front of it. So this would become address of pi. This is pi's address right here, which is in this execution at location 1400. This is going to be address of let2. This is going to be address of let. Okay, so there are two symbols when dealing with pointers. The first one is an ampersand, and that stands for address of. And the second one is a asterisk, and that has two meanings in the language C. It's for declaration of pointers, and it's to get to the value at. Now, there isn't much reason to declare pointers and access them with the address of and the value at both in the same function. The reason that you would use it is when you're going to pass things by reference to another function, which is what we're trying to get to. But in order to get to that, you need to have a basic understanding of how this works. So if I were, though, to put them in the same function, I could declare a character pointer, call it C pointer. Now, when I declare this character pointer, I'm using the asterisk for declaration, and I am declaring a pointer of type character called C pointer. Now, what happens when I do that, I get a character pointer, C pointer, and that pointer isn't pointing anywhere. So it is of no use to me. It does me no good because I have not had it point anywhere. Now, in order for it to be of use to me, I need to point it somewhere. And I have a choice. I can point it to either the address of let or the address of let2. And the way that I point a pointer somewhere, I cannot point CPTR to the address of pi because pi is a double and CPTR is a pointer to a character. So in order to make this CPTR have any use to me, I want to point it to a character that exists in my program. And what we're going to lead up to is how you're going to pass by reference to functions, and then it's going to make more sense, because here it doesn't make any sense for me to have to deal with let or let2 and also the value at CPTR. It's redundant. But in order to understand what's going on, I'm going to be redundant. So I'm going to point my CPTR, and it's going to point to the address of let. So when I make this statement right here, my CPTR no longer points nowhere. It is now going to point to location 500 in this example, which is the same place where let is. So now within this same function, I have two ways to get to this value here. The first way is by the variable let. The second way is by dereferencing. This is called dereferencing the pointer CPTR, going to where CPTR points and getting to that value. And that is, in the way that I do it, I would say value at CPTR. So value at CPTR and let or let are the same thing. And address of let and CPTR are the same thing. Address of let and CPTR in this example both store the value 500. That value 500 is not an integer that's useful in my program. It is a location. CPTR points to location 500. Address of let points to location 500. I don't care what address it points to because in the next execution, it's going to be at a different location. What I care about is the variable called let. The variable called let, and another way to get to the variable called let is to go through the pointer CPTR and get to the value at CPTR. So in the next video, we're going to go into more detail about how you can pass by reference to functions